Okay, this is lesson 18 problem set. It says multiply. The first one has been done for you. So if you notice, they took 2 3/10 and made it 23 tenths. And they took 1 8/10 and made it 18 tenths. Because if you remember previous lessons, we talk about that decomposing where you push all the numbers to the last digit. Guys, you need to stay seated for now. It's pay attention time, not turn in work time. Okay, so I've gone over and I've done this. I saw I have 2 3/10, so I turned it into 23 tenths. My 9 tenths became 9 tenths. And then you set it up just like you've been doing. Multiply the numerators. 23 times 9. 10 times 10 is 100. Then you come over here. 9 times 3 is 27. 9 times 2 is 18. Carry with the 2 would be 20. 10th times 10th equals, so it's 207. Remember, if you have your place value chart, that means the 7 would be in the, what place would it be in on your place value chart? Can I see your place value chart, Ruth? Anyone? Just that one's fine. Okay, look, we have 207 hundredths. So that would be all right here, and you guys probably want to be using your place value charts if you can't remember how to do this. 207 hundredths. How do we spread those numbers out? What do we have to do? Connor?
Well, you have to actually make them go over two spaces.
Okay. So each number goes over, so the 7 stays in the hundredths, right?
Yeah.
And my 0 goes in the,
10.
and my 2 goes in the
Ones.
ones. So I would end up with 2 7 hundredths. Instead of 207 hundredths, I would end up with 2.07. Because if you remember in the video, if I have the number 207 and I have 100 on the bottom, my numbers go how many places to the right? 2 places to the right, so that 7 would go there, and the 0 would go here, and the 2 would go there. So let's look at the next problem. What am I going to put my 6's above? What's that going to look like? Number 6, what do you think? What is my 6.6 going to go on top of? Do you remember? Okay. Good job. 66 over 10 times 15
28 over 10.
times 28 over 10. Equals 66 times 28 over, what's 10 times 10? 100. Okay, we can also solve it this way. 66 tenths times 28, what's going to go after it? Tenths 6 times 8.
48.
48. Carry my 4. 6 times 8 again is
48.
48 plus 4 is
52.
52. What do I do down here? Add a 0. 2 times 6 is
12.
2 times 6 is
12.
plus 1.
13.
Am I done with that? What do I do? What do I do, Camden?
You have to see how much memory, or instead of both tenths, and then I'll have to do 2 numbers behind the decimal.
Okay, so it's tenths times tenths is hundredths. So I'm going to, if I move every number 2 places to the right on your place value chart, what would I end up with?
18 and 48 hundredths.
18 and 48. Since you have a lot of writing, make sure you circle your answer. I don't have to solve this one because I just solved it over here. This would also be 18 and 48 hundredths. So basically today what they're doing is they're just showing you 2 different ways to solve this. Yesterday they showed you the chart. Today they're showing you this process. They call this standard algorithm. I do not call it standard algorithm.
What do you call it?
My standard algorithm looks different to me than this. This would be Engage New York's form of standard algorithm.
Is that one with less than 19 numbers?
Hold on a minute. This, let's do this problem down here, and then also I think I need to show you what to do with the little thought bubbles that they have on the next page. So this is going to be what? Let's see, number 27. What do you think?
I think it would be maybe like 2 and then
Let's decompose them. Throw them all in the same box. What would you get?
2, 3, 7.
Okay, and where is the last digit on this? What place is it end in?
It's in the thousands,
No.
hundreds.
Okay, so I'm going to put over, what am I going to put over?
22, 37,000 or 100.
Okay, over 100 times 19. 9 over 10. Then I'd have 237 times 9 and 100 times 10, which would also equal 1,000. So 9 times 7 is, what is it? 63. 9 times 3 plus 6. 33. 9 times 2 plus 3. 21. 10 times 100, it is how many numbers will be behind the decimal? 3 numbers behind the decimal, that would be 2. See, you guys looked at it and you panicked, but it's actually not that hard, is it? Okay, we got it? If not, you can look at mine later. Okay, let's look at the second page. So what they want you to do is show how you got to this point. So if we have 3 2/10, what do we got to do to get rid of the decimal?
We want to add the move it over to the right.
Okay, by doing it times 10, right?
Yeah.
And then 6/10. Oops, I'm looking at the wrong one. 1 2/10. Move it one place to the right, and that would give me another 10th, right? So far, how many times have I moved these? How many times?
One.
I moved that one once, and I moved that one once. So, what do you think I'm going to end up with? Tenths or hundredths? Hundreds, because I've made 2 places, right? And when you move the decimal 2 places, you end up with hundredths. That's another way to look at it, okay? So moving that bubble, so once I multiply it out, I have to put the decimal back. So 2 times 2 is 4, 3 times 2, 6, 0, 2 times 1,
2,
3 times 1.
3.
Glad you guys know your 1s and 2s, that's good. Makes me proud. And 10 times 10 is?
120.
Okay, so we have 384 as our answer. But now we have to put these back. So I'm going to put one back. And I have to put the other one back. See how that works? Yeah. So the whole thing is, first you move the decimal to the right to get them out of there. If I would have moved this 2 places up here, I would have had to go down here and go 2 places first, right? So when you move it out, you've got to move it back in.